Hello all, good morning. This is Dr. S. Subbalakshmi, Assistant Professor in the Department of Mathematics, SNS College of Technology. This is a lecture cum activity video on the topic two-dimensional random variables. Here we have a problem on two-dimensional random variables. The problem goes like this. We are given with the joint probability density function of the random variables x and y. F of x comma y is equal to xy squared plus x squared by 8. And the x's range is between 0 to 2 and y's range is between 0 and 1. Here you are given with the ranges for x and y as well. And you are asked to find the probability of x greater than 1 given y less than 1 by 2, which deals with the conditional probability. And the second question is probability of x less than 1. And the third question is probability of x plus y less than or equal to 1. Now we start with the solution of the problem. The solution of the problem starts with the first question. We are going to find the probability of x greater than 1 given y less than 1 by 2. This deals with the conditional probability, and the formula of conditional probability, probability of A given B is equal to P of A intersection B by P of B. It is on the denominator on the LHS side, will be there on the RHS too. Now we have this formula to compute this particular question. Probability of x greater than 1 given y less than 1 by 2 is equal to probability of x greater than 1 intersection y less than 1 by 2 divided by probability of y less than 1 by 2. So now we have the formula like this. Now we are going to find the numerator and the denominator separately. So the numerator will be probability of x greater than 1 comma y less than 1 by 2. What is the formula to find the probability of a comma b? So which we have like double integral minus infinity to plus infinity f of x comma y d by dx. Since we deal with the two-dimensional random variables, we are having the two variables here and its range varies from minus infinity to plus infinity. Now we'll have a student to perform the formula of the given function. Now we have a student to say the formula to find the probability of the given question. What is the formula to find probability of a comma b?
Double integral minus infinity to plus infinity f of x comma y d by dx.
What this integral corresponds to?
Y.
Limits
Y.
y. And this corresponds to?
Yes, x.
So this corresponds to y variable and this corresponds to x variable. What is f of x comma y? This is the density function given in the question. Now we will fix the range of the given variables y and x here. First we will fix the y variable here. Its a start from minus infinity to infinity, and you are given that y less than 1 by 2. Y less than 1 by 2 means it starts with minus infinity and ends at 1 by 2. But here your range is starting from 0. Therefore the lower limit will be 0 and upper limit will be 1 by 2. In a similar way, you are going to fix the limit for x. Your x range is 0 to 2, but you are given with x greater than 1. So the lower limit will be 1 and upper limit is infinity, and here it is 2, therefore it will be 2. And what is x comma y? F of x comma y, as I have said you earlier, this is the distribution function given, which is xy squared plus x squared by 8 dy dx. Now on integrating with respect to y first and with respect to x second, and substituting the definite limits given here, we will be finding the value for this particular probability of x greater than 1 given y less than 1 by 2. Now we are going to perform the integration of the given question. The first variable of integration is y. So on integrating with respect to y, we have xy squared here. X is a constant, and on integrating y squared, we have y cubed by 3 plus x squared by 8 is a constant, and on integrating it, we have y here. And within the limit 0 to 1 by 2. On substituting the limit, upper limit minus lower limit, after completing you will be having the value like this, x by 24 plus x squared by 16, and on the remaining things remains the same here, which is the variable of integration x here. So on integrating it with respect to the variable x, you have x squared by 2 into 24 plus x cubed by 3 into 16, and on computing it using the definite integral concept, you will be having the value as 5 by 24 here. And moving on to the denominator here, what is the denominator? Which is y less than 1 by 2. So similar way, we are going to use this particular formula here. We are given with the range for y alone, which means x remains the same. X ranges in from the given question, which is 0 to 2, and y ranges less than 1 by 2, which means 0 to 1 by 2. F of x squared is xy squared plus x squared by 8 dy dx. This is what we are going to do for this particular denominator also. Now on computing on the integration or performing the integration in a similar way as we have done in the previous topic, we will have the value to be 1 by 4. Now we have found the numerator for this particular thing and the denominator value is 5 by 24 and the denominator's value is 1 by 4. Now when substituting it, we are having the probability of x greater than 1 and y less than, given y less than 1 by 2 is equal to 5 by 24 divided by 1 by 4, which means the value will be 5 by. So this is the value of the given probability. So we will continue the problem in the next class. Today we have a student of AML to explain a concept on the problem two-dimensional random variables, wherein the concept of design thinking has been implemented in the problem which has been taught earlier. This particular problem has been taught in the class and in the lecture video as well. That particular problem has been put forward into the design thinking concept and that particular problem has been explained by this student here. We will now have a look onto the problem.
Good morning everyone, I am Sri Shankari. Today we are going to already know this problem with two-dimensional random variable. Today we are going to solve this problem based on design thinking. This is a problem statement that is called the empathy part. So we already know that design thinking have 5 steps. Empathy, define, ideate, prototype and test case. So this is empathy part and the given information from the question is called the define part. And the formula by applying solve this problem we are using the basic formula and continuous random variable formula, and these formulas are called the ideate part. And by applying this formula to solve this question, get an answer for the function is called the prototype part, and the same things happen in the next part. And this is our test part. By applying prototype and get a final answer, that is called test part. Thank you.
Okay, this is what our student has explained as a design thinking approach of the problem on two-dimensional random variables, wherein she has given that this particular problem can be wholly taken up as the empathy part, that is the problem statement. That particular problem statement can be defined in the solution part, wherein the given questions and information carried out as the defined part. Later on,